What is Ohm's law? Ohm's law states that the electrical current flowing in a circuit is proportional to the voltage and inversely proportional to the resistance. That may be confusing. So we can do a visual demonstration to put those words into a visual picture. We are going to power an LED from a DC power source. We will set the DC power source to 5 volts. We are going to get this 5-volt power supply and also find an LED. An LED looks like a diode with arrows coming out of it, and just to demonstrate, if we connect this LED directly to this power source by positive to positive, and negative to negative, and we need to connect the ground symbol in every circuit. Let's run it. We've just blown our LED up, and the reason we've blown it up is, if we click on the LED and view its properties, we can see that this LED's voltage drop is 2 volts, that's the voltage the LED requires, and to light up, the current it draws at 2 volts is 20 milliamps. So we're supplying 5 volts to a 3-volt LED, and that's bad, because it's drawing way too much current, so it just has blown up. To handle much current we need to introduce a resistor to this circuit, so let's add a resistor between LED and power source in series. This resistor is set to 1 kilo ohm. Now, we can see the current flowing through the circuit. We've only got to 3.19 milliamps. And if you remember, we look at the LED's properties, it requires 20 milliamps to light up and 2 volts. It's only getting 1.81 volts and 3.19 milliamps, so what we need to do is calculate the resistance that we need to introduce to the circuit to meet the conditions that this LED lights up at 2 volts and 20 milliamps. So this is where we start to use Ohm's law. We've got V, I, R, that V is voltage, I is current, and R is resistance. So the unit for voltage is volts. The unit current is amps. And the unit for resistance is ohms. Now, we need to calculate the correct resistance for the circuit to light this LED. We've got an LED that requires 2 volts but we're supplying 5 volts, so to limit the current of our LED, we need to keep 2 volts for our LED, so if we take away 3 volts from the 5-volt power source, then we are left with 2 volts, and so this is where we will use Ohm's law. We need to introduce a resistor to drop that additional 3 volts, and limit the current for the LED, so now with that 3 volts, we can calculate the resistor value. We need to drop those 3 volts and supply the LED with 20 milliamps. If we go and have a look at our Ohm's law triangle, then we know 2 values, current and voltage. The voltage is 3 volts and the current is 20 milliamps, so we're looking at this equation. Here resistance is equal to 3 volts over 0.02 amps, so we always write the current in amps in our equation, so if we calculate it, 3 volts divided by 0.02 amps is equals to 150 ohms. We need to adjust this resistor to 150 ohms. And I've put a voltmeter across the resistor here to show that this resistor is taking the 2 volts away from the circuit and limiting the current to 20 milliamps. So now because this resistor has taken away 3 volts from our 5-volt power source, we're left with 2 volts in our circuit which is powering the LED, and the resistor is limiting the current to 20 milliamps. So our LED is now being provided with 2 volts at 20 milliamps, and that's the current that we require to light our LED as specified in the LED's properties, 2 volts and 20 milliamps. Now we can go ahead and do a visual demonstration of what Ohm's law states. So it states that electrical current in a circuit is proportional to the voltage and inversely proportional to the resistance, so while keeping the resistance in the circuit the same, I'm going to adjust the voltage by increase this 5-volt supply to 6 volts, so I've added 1 volt. And we can see here that the current has increased, so as I have increased the voltage. If I decrease the voltage in the circuit to 4 volts, we can see the current in the circuit has also decreased, so we are now down to 6.4 milliamps and that LED is barely lit. I'm going to set this back to 5 volts, and now we are going to adjust the resistor value while keeping the voltage constant or keeping the voltage the same. So Ohm's law states that current is inversely proportional to the resistance, and to show what that means, if I increase the resistance to 300 ohms, so the current decreases, and if we decrease the resistance, now I'll take that 50 ohms, if we decrease the resistance the current increases, and technically we are providing way too much current to that LED will blow up. So look forward to more videos where we will do some more demonstrations. Don't forget to subscribe my channel for more videos.